So hey guys, welcome back to another lecture. So today we're going to discuss differentiation rules, right? So in our previous lecture we have a great detail on the differentiation. I hope you loved that lecture. So today we're going to discuss what are the rules. Like we have a multiple rules, like we have a constant rule, power rule, sum rule, difference rule, and we have a exponential rule, logarithm functions, and the product rule, coefficient rule, and we have a lot more. Like we have a 12 kind of rules, 12 kind of a differentiation rules. Like, so I'm going to discuss in a great detail, explain one each and every rule. Okay, at first, so I just want to give a formal definition for the finding the derivative, which is dy by dx. If we have a derivative of a function, right? We have seen the previous lecture, so how we find the derivative of this function. This is a difference coefficient, right? So we have a y2 minus y1 by x2 minus x1. We have this formula, right? So it is a derivative of the function. So at first what we have a constant rule. So I'm going to discuss what is constant rule. So by the word you can understand the constant rule means like it's a constant. It's a function that is equal to the constant. Low means like it's a constant, means like what? 1 2 3 constant k, right? So we have a function which there are no x and y, there is no y error. This is a function for we, right? So we don't have x here. Okay, we have only 5. So if you find the derivative of this function, which is f of x is equal to 5, then our answer is become 0. There is no x to find a derivative of that function. Okay, so there are no x to derivative of that function. If you have any, then we can simply do the calculations and we get our derivative. But here we have a constant, so it is equal to 0, right? So the derivative of f of x, which is respect to the f of x, is 0, right? So we simply take that derivative of that function and we can simply say that if the derivative of that constant is equal to the 0, right? I hope you're getting it. We can write in many ways, like we use dy by dx, or df of x by the dx, or df prime etc, all are equal to 0, means it's constant here. So I hope you've given a best example like that what is constant. So if you find the d of x into 10, it will become 0. If you find the d of x into 15, it will become 0. Means like the derivative of constant is 0. Okay, so after that we have a power rule. So what is power rule? Power. Okay, so the power rule is you simply take out the power and bring in front of the coefficient of x, and then we subtract with it. So what is these all thing, the blah blah blah. So if I have a function x power 5, right? So what is the power rule? Means x power 5, the 5 which it brings into in front of x, which like if it will become it in front of x, and we simply subtract 1 from the power. Okay, so we have a x power 5. Okay, we have a x power 5. So if we use the power rule here to finding the derivative of that function, we simply take out the 5 and we bring it in front of the x. We just simply taking out the, and we just simply bringing in front of the x, and we simply subtract with 1. I hope you're getting it. And the value will become the fx power 4, which is our derivative. Okay, so you can try it with x is equal to 10, and it will become 10x minus 10 minus 1, which is equal to 10x x power 9. This is our derivative. Okay, so if I want to find this to the derivative, means I want this function to have a derivative. So how it gonna be like? So then we have a constant multiple rule. So I just want to find this, means like so we have a 4x cube, right? So how we gonna find it? Here a construct is multiplied with the equation, means like this constant, right? So this constant is multiplied with the power rule, means we have a, right? So we have seen the power rule here. We just simply multiply with the constant here. So this constant multiple rule. So I hope you're getting it. So with the help of the power rule, you're going to get it. So if for example we have a 4x cube here. So for example we have a 4x cube here, and we just simply find the derivative of that function, means that 4 into x cube here. So with the help of the power rule, what it will become? The 3 will become the in front of the x, and the 3 minus 1 here. which is same as here, so which is equal to 12x square, which is our derivative, right? So it's just a simple thing to understand, like how we use the constant multiple rule. And then we have a sum rule over here. So what is sum rule? We're just simply adding the number of equations here. We're just simply adding. So we have a x power 5, x power 4, x power 3, x power 2, and xn plus 10. So we have a long equation here, but we just simply add that. We just simply add those functions here. So with the help of the power rule, with the help of the power of the 5 bring in front of the x and the 5 minus 1, right? So 4 minus 1, 3 minus 1, and 2 minus 1, and then we simply the derivative of the constant is 0. Okay, so we just find our derivative of that function by using the sum rule here. So we have a plus over here. We simply add these functions to find the derivative. Okay, so what is difference rule? We have discussed the sum rule, right? So then what is difference rule? It's just similar to the sum rule, but we have a subtraction over here. So we have the same equation here, bro, but we use this subtraction here. So we find the same by using the power rule here, and this is our derivative. Instead of plus we take minus, that's it. Okay, I hope you're understanding. Like, so we have discussed until like what we have discussed the constant rule. So we just means that the derivative of constant is 0. Okay, so what is power rule? So we just simply bring in front of it and we just simply subtract with 1. So what is constant one? With the help of the power rule, we just simply calculate with the constant. So what is sum rule? We have addition over there, we add the equations here. So here what? We just simply subtract the equations here, and we have a differentiation trig functions. So we have seen the trig functions, right, in our previous lectures, where there are 6 kind of trig functions, which is sin theta, cos theta, tan theta, and their reciprocals of it, right? So we have seen the 6 type of trig functions. So we're gonna find the differentiation of that trig functions, like the dy by dx of sin x is equal to the cos x, right? So I'm gonna zoom it a little bit so it will be easy to see. So the derivative of sin x is equal to the cos x. We all know that, right? So I'm not going to explain like how this came. So I just want to explore it on the internet so that it will be easy for you to understand. So how the derivative is taken, etc. So okay, so we have a derivative of cos x, which is equal to minus sin x, right? So after that we have a derivative of tan x, which is secant square x, and we have a derivative of cotan x, which is equal to the minus cosecant square x, and we have a derivative of secant x, which is equal to the secant x tan x, and we have a derivative of cosecant x, which is equal to the cosecant x and the cotan x. So I just wanted to explore it on own. Please watch a video like how we find the derivative of that. So how we take the derivative of the sin x and how we take the derivative of the cos x in the YouTube. So it will be easy for you. Like if you see one video like in the sin x, and the process is same for all these functions. Okay, so I just want to explore it your own. This is your assignment. Okay, this is your assignment. So we have discussed until 5, and I just want to discuss the exponential functions. So what are the exponential functions? If we have a e power x, then this is called as an exponential function. So I just want to give an example. Like, so the derivative of exponential function is the same of e power x. Means like, for example, I just want to give a formal example. So for example, if we have a 5 e power x, okay, 5 into e power x. So this is a constant multiple, right? We have discussed in the previous rules, right? So 5 into e power x, right? 5 into e power x. So what is the value of this? This is simply equal to e power x. And then we simply write this. This is our derivative. I hope you understanding. Like, so the derivative of this e power x is equal to the e power x, same as this. I hope you understanding, right? So this is an exponential function. So after that we have a logarithmic function. So what is logarithmic functions? So here we have a log. That's it. Here we have a log. So why we use log here? We use log in our regularization methods and normalization methods in the linear regression, and a lot more in our models. But as of now, like just have a basic idea like how we use the log in our differentiation. Okay, so we have a log. we have a log on both sides, like logarithms. So if you have a function like this, if you have a function like, which is, it means like ln means a natural logs, okay, ln means natural logs. So if you have a function like this, log base e for x, and so I just want to find a derivative of that function. So means like if the derivative of the log x is equal to, it will become the 1 by x, okay. This is a formula, okay. So this is a formula. So for example, I have a log base 10x, okay. So I just want to find, so what is the formula this, so what is the from the equation, you can say that, and we have a log 10 over here, okay. So what is it, so it will become like what, it will become x log 10, if it goes up, and it will become log 10 by x, right. We simply cross multiply it, and it will become 1 by x log 10, and this is our derivative, okay. This is our derivative. So the ln or log, they are both equal. We use ln for the natural logs, okay, and we use log for usual logarithms, okay. So if the log base is a number, then other than c, means like if the log base number other than c, then we tweak the derivative a little bit. So we are tweaking, if the log base is a number other than c, means like the base which we have here 10, which is other than c, which is not a constant, then we simply tweak our derivative. I hope you understand it. Like, so what is the tweak? Means just we simply pull, so we just simply pull or improve our derivative a little bit to find the derivative. So after that, we have after completing the logarithmic rule, we have a product rule. So what is the product rule? So if f of x and the g of x are differentiable, so if they are differentiable, then the f h prime x, which is equal to the f of x into g of x, means like the derivative of this function is equal to the multiplying with the product. We are finding the product with these two, so we just simply multiplying these two. So if I have a function like this and we are producting this f of x into g of x, first we take out the f of x and we find the derivative of g of x, and then we take the g of x outside and we find the derivative of the f of x function. I hope you're getting it. So the formula look like, means like f of x g prime x into plus g of x f prime x, same as I said in our. So we just simply take out this and we find the derivative of that, and then we simply take out g of function, and we just simply take out the f function. So I just want to give a formal example so that it will be easy to understand. So we have a x cube sin x, okay. I just want to find the derivative of that function. So I just simply take out this and we find the derivative of this function, and I just want to simply take out the sin x, and I just want to find the x cube derivative, right. So I have done the same process here. So the x cube here, the derivative of the sin x is equal to cos x, as we discussed here, right. So after that, so the sin x into the power rule here, here we have a power rule, and then this is our derivative. This is our derivative for the product rule, okay. So that I just want to try out with the x power 4 into cos x, or x power 5 into tan x, or x square cos theta into x cube sin theta. So I just want to explore it on your own, so it will be easy for you. So I didn't want to be spoon feed you that teaching everything. I just want to explore it on your own rather than just simply watching these videos. So if you watch these videos, it will be no sense. Like if you don't practice it, it will make no sense for teaching, okay. So after completing the power rule, we have a coefficient rule. So what is coefficient rule? So how we find the coefficient of two functions? So if we have two functions over here, so I just want to find the derivative of this function. So we just simply multiply with this. So it's just a kind of a power rule, but we have a coefficient over here. So we just simply bring out the g value here, and we find the f of x value, and then we simply bring out the f of x value and we find the derivative of this g of x function. So same as I explained here. So we have a g of x into f prime x minus f of x into g prime x divided by gx square, right. I hope you understanding. Like, so this is a similar to the power rule which we had discussed in the previous, right. I hope you're understanding. Like, so if you have these kind of function, then we simply first we take out the one equation, one function, and then we find the derivative, and then we simply minus. So we just simply take it out and we find the derivative of that remaining function. Okay, so it's a kind of a simple, it is just simple to understand. Like, so after that we have a chain rule over here. So it is a product of inside and outside function. So it's just a product of inside and outside function. It doesn't make sense to you, right? So what is the inside and outside function? So if we have a f prime g of x into g prime x, if we have a derivative of that function, like, so if you have a f prime g of x into g prime x, so I just want to give a practical example so that it will be easy for you to understand. Okay, so if you have a y is equal to 3x plus 1 all to the power of 6. Okay, so I just want to find the derivative of that function. So with the help of the power rule, the value become here. So we have a formula here. So if you carefully look at the formula here, so this 5, the derivative of the outside function by using the power rule. So this is the derivative of the outside function by using the power rule, and this 6, which is the derivative of inside function by using the sum rule. So we are using sum rule here and we are using power rule here. It's the both combination of the power rule and the sum rule. Okay, by the word you can understand this chain means, like, it means combining these two, means that how the chain look like this, the chain look like this, right? So this is a chaining, means combining two functions, which is here power rule and sum rule. So we just, with the help of these sum rule, we just simply multiply these two and we find our, if we get our equation here and we find our derivative here. Okay, so this is a composite function. So this is a composite function, right? So if you clearly watched our previous lecture, so I have discussed what is composite function. If we have one or more functions inside one function, this is called as composite functions, right? So we have a f y prime, which is equal to the f prime g of x into g prime x, and this is outside derivative and this is inside derivative. This is the outside derivative and this is the inside derivative. So I just want to try out a new example so that it will be easy for you to understand. Okay, so after that we have a logarithmic differentiation. So what is logarithmic differentiation? So we just simply take the log on both sides. That's it. We just simply take the log on both sides. So if we have a function like x cube minus 5, we just simply take out the log on both sides. So if we have seen the logs, right? So we can write ln also, which is natural logarithms. These both are similar. Okay, so how we find the log, right? How we find the log of f of x? So the f of x is equal to x cube minus 15, right? So it will become like 1 by x cube minus 5. In our previous rules, like we have discussed, like f of function, like f, which is like a log, it will become 1 by x, right? Log x will become 1 by x, right? So this is the formula here. So we just multiply with the derivative of that function. Okay, we just simply multiply with the derivative of that function and we will get our derivative here. Okay, so I think I have completed the 12 different rules here. So I just want to give an outline for all to 12. Like, so what is constant rule? So here we finding the derivative of that constant rule. Okay, so the derivative of constant is equal to 0, and we have a power rule. We simply take it out, we simply bring it into front and we find the power rule. And we have discussed the constant multiple rule. So as same is similar to the power rule, with the help of the constant, we multiply with the constant. And we have a sum rule, we have adding the values, adding all the equations, and we have a subtraction over here, and we have a differentiation trig function. So this is a vast topic to discuss, but I just wanted to explore it on your own so that it will be easy for you to understand. Okay, so and we have exponential functions and we have a logarithmic functions, how we find the logs and etc, all this. And we have a product rule, so how we gonna product these two functions and what is the formula over here, how we find the derivative of that function. And we have a coefficient rule and how we find the coefficient and how it is similar to the power rule. And we have discussed the chain rule, which is a combination of a product rule and sum rule. It is a product of inside and outside functions. Okay, so after that we have discussed the logarithmic differentiation. So how we take the log on both sides, and how we find our values, how we find our derivatives, etc. In our next lecture we have, so I just wanted to discuss the integration, and we have a beautiful notes out there. So the integration going to be the last topic of this calculus. I hope you enjoyed this lecture. So until then, bye bye, see you in the next.